Good morning. Good morning, everyone. I am trying to complete the setup, make sure that everybody is admitted, and then we proceed. Participants, I don't think anybody is in the waiting room. We wait for five-ish people, and then we start. Two more. Okay, yeah. Meanwhile, if you don't hear me or my screen is not properly shared, just raise your hand or say it, but it should be okay. I have shared the screen and yeah, everything should be ready to go. We wait for maybe 2 more minutes. I already turned on the recording. Yeah, it doesn't notify, but probably it's doing the recording. So that should be fine as well. Yeah, 30 more seconds and then we start the class. All right, okay. One more time, starting over. Good morning, everyone. My name is Ali Rosek. I'm a structural engineer with HDR in Vancouver, and I will be teaching earthquake engineering this term, summer term in UVic. And yeah, I will try my best to make it enjoyable, and at the same time, just hopefully you will be like ending this class with a little more knowledge than what you started with. As I said, I have been with HDR. I'm new to HDR, but however, I have been in the dam industry for quite a few years. And recently, in the past 2 months, I joined the HDR office in Vancouver. Globally, they are famous engineering and architectural firm. And however, in BC, they have been more famous for architectural. Now they are hiring engineers as well. So there is more opportunity or more choices for engineering jobs in Vancouver and BC, Victoria as well. So proceeding, okay. Make sure that we don't miss any page. Okay, yeah, getting started. I mean, today we want to mostly focus on introduction. And generally, if you guys have a question or a concern, or you don't hear my voice, etc., just quickly unmute and tell me, because I have one single screen and I'm not monitoring text or other messages. However, I try my best to chase them as well. So generally, I know that I used Brightspace. This is my second year. I'm teaching this course. Last year, I used Brightspace. This year, I didn't start it. I kind of remember that I should somehow tell the website or software to get us started. So maybe it's not yet started. I know there are some assistant teachers. I will ask them if I couldn't figure it out. But generally, the intention is to use Brightspace. Let me check one more time, make sure everybody is admitted. Yeah, again, that 25 that I was thinking about. So we have the 25. So Brightspace will remain an important tool. And last year, what we did and what I really like to do is to evaluate the course based on team projects. However, the Department of Civil Engineering has concerns that the students must attend the classes, and I have the responsibility to make sure that the students will attend all the classes. Therefore, I slightly changed it, and now 80% of the course score would be the team project, and I have kept 20% for class presence. Generally, I would be happy if I have like 25 people or more, but if I see that the numbers are dropping, then maybe I will use something like flash quizzes, simple quizzes, just to see who is in or not. And we decide about that 20% score. So generally, I like to keep it easier. I know that the students sometimes even learn better when they read it themselves. There are different personality types, etc. However, yeah, let's keep it above 25 people out of 35. And that would be a nice class. However, this year, still, I keep it the same as last year. There's no assignment, but practically your project is the assignment. And I haven't met Behnam yet, but he has accepted to be the teaching assistant for this course. This year we have, I think, fewer than 40, so one teaching assistant. Add one more person. And here's his email address that he has used to contact me. Yeah, I was busy, so maybe I had to call him earlier, but if Behnam is in the class, maybe he can introduce himself, or maybe he's not. I mean, obviously the class is not mandatory for the teaching assistants, but he will have a chance to introduce himself. His resume says that he has a strong background in earthquake engineering. So, I mean, very appropriate for this class. And here's his contact if you guys ever needed to reach out to him. And I am the instructor. As I said, a lot of my background has been, in many years, has been dam earthquake engineering. I do a lot of earthquake assessment of dams. I have done it in BC and in the US and around the world. So that has been the biggest part of my resume at this moment. Here's my UVic email address, and you are welcome to contact me with your questions and concerns. And this is actually my work phone, my work mobile number, and this is a BC number. I was initially surprised, but this is a local BC number. And yeah, you are welcome to call me for more urgent issues that I have to resolve immediately. All right, let's see if I can minimize this. Hopefully this is not on your screen. Okay. So yeah, just because I said that I have been a dam earthquake engineer or a dam engineer for many years, formerly a structural engineer. So I thought that I give you like a high level overview of what we do in dam earthquake engineering. At this moment, there is huge amount of interest in the clients, dam owners, and also regulators in BC, in Canada, and I mean in the US, everywhere in the world, to carefully study dam response to earthquakes. And what we have been doing many times over and over have been to create models of the dam, the foundation, and the reservoir behind it, and study the response during the earthquake. We try to account for even for the sediment at the bottom of the reservoir if we have enough time or if the project budget allows for this. So here is a simplistic way of looking at those models, or practically the way we look at the models. The wave propagation into the system and using dampers to account for the remote conditions, like the how the waves enter or exit the system. Proper or sometimes simplified modeling of water behind the dam and the dam itself. So sometimes in the bigger model, the dam looks tiny. This one is, yeah, this one is now old, like about 10 years ago, I created a model of Susitna-Watana Arc Dam. At that time, it was feasibility design, and however, this one was supposed or is supposed to be in Alaska, but the Alaska government or their legislation, they never approved a budget for it, but sometimes they pull it out and do a further study, and so far they haven't really approved the full budget. So we created a model of the dam, which is 200 meters plus, and we do some stress analysis and earthquake analysis to find out how the dam will respond to earthquake. And again, the full model where the dam looks tiny and water was properly modeled by proper material properties in a way, characteristics, and foundation and the dam. This one is like from about 5 years ago. This is a model of the Lewis Lake Dam, which is in BC. It's in Sunshine Coast, in city of, very close to city of Powell River. It's a very nice arc dam. The owner was private sector. However, by the regulators basically want them to check their dams regularly to make sure that they withstand the latest estimates of earthquakes, because the estimate of earthquake in BC or in Canada have increased through years. And they asked us to do a study of the dam response to earthquake. And on this side, we had, I was part of the team who did a study on a rockfill dam, which is like this type of dams. They are called tailing dams, and they hold off the tailings of the remaining parts of a mining project. So similarly, this one was in Peru, in South America, and we did an earthquake study to make sure that during the worst earthquake, this tailing doesn't fail. which is again an earthquake study, a dam earthquake study. So that was generally high-level introduction of myself. Now getting back to the course, and what I imagine you guys have familiarity with. We want to do like more earthquake dynamic analysis. So I assume that you guys are already have some analysis background and can complete a static analysis, a static loads analysis. You have some familiarity with the most important materials in structural engineering, which is steel, concrete, and timber, and others. And how the structural load, especially in everyday loads, mean like the dead loads, live loads, wind, snow, and then, earthquake. That's what we do in this course. But I kind of expect that you generally understand the concept of different loads and how to figure them out using NBCC code or other related codes. Also, by the end of this term, we will touch on some steel design and some concrete design as far as it is related to earthquake design. And I assume that you guys already are familiar with the basics for like regular, more daily loads. And so I think these are important that you guys know about them. And preferably, if you know some dynamics, it helps with quicker start or like you can, or a better learning curve in a way. Because this course, the way I inherited it and I modified it slightly, but generally I consider it very comprehensive and very encyclopedia type, like we cover quite a few things in this course. So if you have a stronger background, then you can catch up better. But generally, the way this course was designed and has been offered in several years is in a way combining a few important topics, which each one of them could be a course by itself. But we try to give the students enough information on those topics to generally can handle earthquake analysis and earthquake design. However, each one of those topics really need more, like maybe, like if you want to be an expert in concrete design for earthquake, then that's a complete course. So that's on itself. But as I said, we will cover it as like one session out of 10 or one module out of 10 here, just to touch on the basics which are necessary for consulting work. But for expertise, like everything else, you can go as deep as you want. Now, yeah, if you guys want to, anybody wants to talk and what do they think about these prerequisites or where they are, or do they think that the students really meet these prerequisites? Just maybe, yeah, just unmute your phone and tell me about your understanding. Escape this. Anybody wants to object or discuss further on the prerequisites of the course? Let's see if there's anything in chat. Okay, thank you. Thanks. I also think it's good. Yeah, I think it was developed through years, so there was general agreement and understanding that this is a good idea, like these are achievable as prerequisites or the preferable courses. Excellent. Okay, let's move on. let's go to the overview of the course. Yeah, as the way I divided the course, I divided it into 10 modules. And initially, starting from next week, we will be for 2 weeks at least, but it will normally it extends a little bit more because we need to go through some exercises. And so at least for 2 weeks, we will be mostly focused on dynamics of a structure, as if it's a course on dynamics of a structure. And we cover both single degree of freedom and multiple degrees of freedom. Both will be covered in 2 weeks or more. Then we proceed to one level higher. We look into response evaluation generally, how to evaluate the seismic performance of structures, speaking slightly higher level. And after that, in module 5, or more in 6, we jump into more details in NBCC. So number 3 is higher level. Module number 6 is more Canada related and BC related. In between, we want to have a session just showing you guys a shape table and also compare what shape table results are, which are more like the real results, with what analysis or using software will tell you about the outcome of earthquake, the response coming out of the response of a structure to earthquake. That session, I will tell you more about this. We have planned it for June 7, which is a Friday. On June 7, we will have a 3 hours session at UWIC starting at 11. And so we will ask the people who run the shake table to bring the shake table to the class. Their demonstration maybe takes about 1 hour. And then after that, we spend another 2 hours on the analysis, which is related to shake table test, and maybe we proceed even with the next module. So bookmark your calendar. I think it's June 7. The class is at UWIC. And the previous Tuesday class, online class, will be canceled because we will have the whole 3 hours of that week in the campus. Then after module number 4, after we are done with dynamics of structures and we have presented its validity using a shake table test, we move on to more engineering side. These are engineering, but further practical engineering side, we will discuss some seismology, seismicity, and seismic hazard. This is not exactly a structural engineering, but that's something that structural engineers should be aware of and understand it. We receive reports from seismologists or from geotechnical engineers who also know seismology. And we should at least understand them and know what they are talking about and how to use the data that they provide us. So that module number 5 is a good start. Then in module number 6, we dive into NBCC, National Building Code of Canada, and we try to focus on section 418, which is mostly earthquake engineering and earthquake design. We try to fully understand it. My intention is to use NBCC 2020, and last year I did the same. However, I think last year NBCC 2020 was not legislated in BC, so that was a little bit questionable. right now, I should double check, but yes, it's legislated already in BCC 2020, but I will make sure that it's legislated. And however, I think there should be a preference to learn NBCC 2020 because it's either legislated now or 6 months from now. So it will be legislated by the time you start working. So I still have the preference to use NBCC 2020, but if you guys have concerns, let me know. Maybe we can slightly modify or cover both. The procedures are slightly different, and NBCC 2020, I think in a way it's becoming more similar to the ASC procedures. Then there's the next module, which is also based on National Building Code of Canada, and that's for provisions for non-structural components, which is also very important. Again, this is a subsection of 418, but I think it needs almost one module or one or two classes of its own. We will cover a few important topics there. And we try to spend 2 modules, which means about 2 weeks, on steel, concrete, and wood design, which is very short amount of time, but we try to, cover the basics so that you guys can get started. In some part of it, maybe in wood at least. My knowledge is also only basic, so I don't know all the details. But depending on which area you will be working on, you should know the basics, and then you will extend your knowledge from there. So it's good to cover the basics. And then whichever area you start with, you will learn a lot through your career. One module is for a special topic, and obviously because I'm very interested in seismic performance of dams, I will try to keep it like that. Seismic performance of dams, I will present it myself, but I would consider inviting, if it's not too late, inviting another expert from industry who can cover another interesting topic. But for myself, it's the interesting topic for myself is the performance of dams and seismic performance of dams. So that's my plan now. But if I find somebody that can go high level on, say, wood or dampers or energy dissipation, etc., then that's also another choice. And here we go to the course evaluation. That's almost I copied this from last year. We want to have teams of 3 or 4 members. At this moment, we have a class of about 36, I would say. Maybe we will have 9 teams or 10 teams. The more, the better. And so you guys will complete the project, and I will show that we have some deadlines. We have deadlines throughout the term so that nothing will remain for the end of the term when you guys want to focus on your other finals. This course doesn't have a final. When you guys are studying for your finals, this is already submitted and scored. So nothing to worry about in that sense. Like I guess you guys have already been evaluated for this course. But yeah, there's one change compared to last year. I previously mentioned that I added this last part because your department, your civil engineering department, really requires attending the classes and learning in the classes. And therefore, I separated 20% for class presence and quiz. Generally, I like to be easygoing like last year. Like right now, there are 27 participants, which is a great number. I know that people have different things, maybe daily issues and getting sick, etc. That's generally okay. Or some people have some, commitment. But if I see like the numbers are dropping a lot, then we start having more and more flash quizzes, etc., to gain back your attention and bring you back to the class, because a lot of learning will happen in the class generally. So that's why I reserve 20% for the attending the class, and also I will have some flash quizzes, quick quizzes, just to see who is really in the class listening, can quickly answer a few questions. Yeah, as I said, generally, especially today, every day, every class would be like that, but especially today, you guys can just unmute any second and tell me your opinion, because we are introducing the course. I already sent this one to you guys. That's the outline that I prepared. I pretty much talked about it. My name, and as I said, HDR, mobile number, and UVic email address. Definitely use them, your benefit. Classes are 2 days a week, Tuesdays and Fridays. I think one of the Tuesdays is off, July 2nd is off, so we won't have a class on July 2nd. Then June, as I said, June 7, I already showed this to you, let's jump here. On June 7, we will have Module 4, which is Shake Table presentation. I will be at UVic in Victoria. And therefore, as a result, we don't need, this is a 3 hours class, therefore we will drop the class on June 4th, which is Tuesday. On Tuesday, June 4th, we won't have a class. Otherwise, most of the terms we will have, and here you see there is 1 day, because July 2nd, I heard that it's like a reading break for you guys. And so at the end of the term, similar to last year, we want to have 2 sessions of presentations where the teams, the project teams, they will present their work. And right now I anticipated 9 teams, but I would say, as I said, the more the better. Even if you have, like last year, we had about 12 teams and we had 6 and 6. We can easily do 6 and 6, and in 2 classes, which are 3 hours long, and it's at UVic campus. And especially for these 2, I think everybody must attend, because we are all learning, because everybody is, last year, most of the projects and presentations, more than 50% of them were very interesting, and I learned a lot, and I guess the students also learned a lot. So we will have quite a few very interesting presentations. And this I already presented. References, I will talk about it a bit further. Sub 2000 is required. I guess you guys can obtain a license from UVic on your own laptop. And there is a lab. I haven't been to that lab. I know that there is a lab, so you can even work in the campus using departments, computers, I would assume. But yeah, just let me know or email me if you have trouble installing the software or getting the license, etc. We will use Subtile 2000 in the course, and maybe a lot of students were using it for their projects as well. Yeah, further about this. So as you see, for project, which is the main part of the course, 80% of the course, we have deadlines. And I expect the teams to meet the student teams to meet this deadline, which is, they are not tight. I cannot say that they are tight deadlines, But at the end, you will be very happy because when your other exams, final exams start, you have already finished and submitted your report. So it is rewarding both for me and you and for the teaching assistant that everything is done in time. And then in August, you can, or late July, you can really focus on your other final exams to prepare for them or for the projects which didn't have deadline. And by the end of July, you can say, okay, I learned a lot, or I somewhat learned something at Quick Engineering, and this course is over. I will just present my work on 26th or August 2nd, just randomly we will pick teams for these 2 days. So remember the deadlines, and I try to, or I will enforce those deadlines because everybody will benefit from the deadlines. For evaluation, I already showed you this. So again, yeah, every step. Let me see, there's something in chat. Yeah, okay, yeah. As I said, I have used the Brightspace one time. I know that it's there for me, but I remember vaguely that I should click on something to make it available for everyone. I will make sure that this is done in maybe it's late for today. Next week, I will reach out to Armando or somebody and ask for help. But we make sure that it's going next week, about next week. I will be posting the slides there, and I try to, starting from next session or next week, early in the week, send you the slides so that you guys, if you want to prepare or have a glance earlier, we can do that. Video recording, I posted last year, which was okay. So I can do the same thing. Right now I'm recording. I think I'm recording. It doesn't say anywhere, but I'm recording. But yeah, but then if there's any issue today, I will resolve it for the following weeks. And I will make sure that even the video recording of the class is posted on on Brightspace, so everything will work out. And you guys will submit your work through Brightspace. If I couldn't figure out, I will contact somebody in the department to help me. Already, so these things, suggestions. I think I had suggestions in the other slideshow as well. Templates, okay, yeah, should show you the templates. I send the templates, I prepare templates for the work plan and the report so that you are not lost. You generally know what I am looking for and what the teaching assistant Behnam is looking for. I slightly updated it a couple of hours ago and send it to you. First of all, so part of this exercise is that, and we did it last year, I think, in my surveys, more than half of the students were happy about this. There were some people who were not exactly happy that I asked that the students come up with the topic themselves. So I think it's a good idea. Maybe 60, 70% were happy about this. However, if you are concerned, email me or call me. I will try to help you with finding a topic. But at this moment, I decided that to keep on doing the same thing as last year, and you create your own team, and then in your team you decide about the topic. But both of them can have challenges, obvious challenges. Some students might not find a teammate, and we can help. I can help people meet each other in a way, and you create the team. But both of them had like 70, 80% success, about 70% success last year. And then I can help, or Behnam can help the other 30% find their way, which is okay. I just try to like create a template which somehow resembles the reports that we create in the industry so that you guys have a sense of that as well. Just somehow fill in the blanks in a few places, a proper cover letter for each one of those documents. similar to what we do in the industry, in civil engineering, structural engineering industry for the reports. Proper table of contents, the list of tables and figures, and the list of appendices. And this is the work plan. That's what you will submit first. And you submit a draft, so you have two chances. Like you do your best, you submit a draft, and then I myself or Ben we will comment on it. Then you have a second chance to improve it even for better. Don't overpromise or underpromise. Don't make your life difficult. But then if you underpromise, then we tell you that's too easy, and maybe you have to do more. Or even if you overpromise, I try to capture that as well and just keep it at a level that you can handle, and your team can handle it. And you tell them about the background, why you think this project is important, and objective of your project, and say, we had a meeting on May 20th and with my team, with our team, these people, and we had a discussion on how to proceed. Here are the data that we require, and here's how we obtain it. Like last year, even on this, you should be careful. Like last year, the students wanted to obtain the, say, structural drawings for some buildings in UVic, and it took too long, and then they had to approximate. So obtaining some of the information that you want is not as fast as you may assume. Sometimes it's like paperwork and approval, etc. Software requirements. SAP 2000, a lot of people use or don't use. Either way is fine. And then you better use Excel or MATLAB or other software, and then other subtopics for it's kind of your proposal or your work plan. And this section, I call it report. It's not reporting, it's just describing, like trying to imagine how your report will look like. You will say, our team report will have these subsections, and we will discuss these issues. So in that way, when I look at your work plan, I can judge, okay, that's enough. They are going to do quite a few important things in their report or meet some objectives. That's what kind of dictated that you have to deliver the work plan and the report and the presentation slides, and those are mandatory. And you can just promise that you will send your SAP 2000 model, or maybe not. And you can acknowledge the deadlines, which are in the outline that I send you. Acknowledge that you will meet those deadlines. For your presentation day, I try to, after I know how many teams we have, I can randomly pick for the 2 days that we have for presentation. And here's a list of team members, and you can assign different roles if there are different duties in your projects. Divide the roles already so that everybody is committed. And a very brief CV of the team members also. Include that for every member 1, 2, 3. Say it's like third year student or fourth or fifth, and has done some co-ops or not. Just explain that a little bit. Appendix number 1 also is mandatory here. Just want to, as I said, I don't want teams to overcommit or undercommit. So for the mandatory milestones and also for other milestones that you create yourself, try to guess each team member how much time they will spend on it. I think this is from last year, but last year I had thought about it. So I thought that about 36 hours is enough. So every team member, if they try to spend plus minus yeah, just estimate, try to guess. Like say somebody says I like too much, I will spend 44 hours, that's fine. Another person says I want to spend 34 hours, that's again okay, but that's good for your own because you know how much commitment you have and you spend that amount of time and you finish the project happily instead of getting anxious. Yeah, again, you can. That's what we do for our proposals. Like we add CVs. So if you like add your CV as well and any other appendix that you think it's necessary. So that's the one that you will start with. And then after the work plan is reviewed by us and approved, then you start working on your final report. And for final report, the cover sheet is the same. Cover letter, proper list of content and tables, figures, appendices, etc. And like, remember that you already promised in your work plan to present your report in certain way and have certain titles in the report. So you can just copy it from there, bring it here, and fill up the spaces, introduce, tell the purpose of a study, and go through your project similar to, I think you have done tens of reports, so maybe you are a lot better than me, but at least see this minimum requirements. I also want you to, again, at the end, one more time, go back to that table and fill up this form and say how much you really spent. Again, this is good for your own good, and in future, you have always to work with certain level of time and budget. So it's a good exercise for that as well to know I had 36 hours to finish this, but I spent 40 hours. That's fine. You write it down, but or I spent less or more. And this is a good exercise that's again related to industry. And I think it even gives a peace of mind because you know how much you committed and you do that, not more, not a lot more. Some students do a lot more and some delayed until they become anxious. So you can, if you want to avoid all of that, just do the task and be happy about that. And then your project probably will have other appendices based on your work. So you can add appendices. Again, if you have questions about this templates, these two templates, just email me. I can answer questions. Well, now I close them. Back to the introduction. Okay, so you know what we want to do. We want to write a work plan, then proceed to the report, do the project, do the report, have some presentation slides, and then present it to the class. That's the main task that you will be scored for. Project suggested topics. Yeah, that's just, I just did some brainstorming, which, well, I mean, what would be interesting for students or for their future role in the industry. Very good understanding of NBCC, it's always rewarding. So if we can like do some research on background of some of the, or go through the commentaries of NBCC. I think previously 2015 commentaries were available, but I couldn't really download 2020 commentaries, or maybe I didn't look hard enough, but I'm pretty sure that 2015 commentaries are there. You can really do a good research, understand part of NBCC that you are interested in. And even if you do a exhaustive research, that's good enough. You don't even need to use software, but do exhaustive research and understand it and look at some papers, or maybe use some software to do your own study and understand the commentary. That would be great. That would be very important for your future work in earthquake engineering. Site-specific seismic hazard assessment, if you understand that, that's also nice. I mean, it's done, a lot of times done by geotechnical engineers, but I know structural engineers who have changed career to seismic hazard assessment, which is very nice. And it's I think, I mean, I never dive deep into it, but it looks like a somewhat difficult or mathematical field as well. It needs good understanding of probabilities and probabilistic analysis in a way. Shake table and material testing, again, that could be a good research topic. The students normally, at least one thing becomes excited about base isolation and energy dissipation. It's a very interesting topic. Last year, we had a very good presentation. And so if a team decides to follow up on that, I can send them the previous year report and they can just expand that further or become more specialized in one of the topics there or a different one that they didn't cover. That always causes interest in students. Assessment of existing structures and retrofit. We had some discussions last year, so I think some students would be interested in that part. It involves some analysis and design and understanding the retrofit or even interviewing companies who are famous for their retrofit work and trying to describe their work. That's also very interesting to students and myself. Or you can do as if you want to do earthquake analysis and design of a steel or concrete, a structure or bridge. Yeah, timber is also accepted. However, I have more mediocre knowledge of timber, but they're completely acceptable. Dam earthquake engineering, I would be excited. Last year we had one presentation. Again, I can share that presentation and we can go, or the team who is interested, they can go further on that topic. And then just even earthquake risk management, some people are interested in that, or this is a very specialized topic in analysis. If you want, I can send you resources or anything. Just tell me if you find something very interesting, and I can quickly say or try to say if it's too difficult or too easy or appropriate. Generally, the references, the most renowned reference for earthquake engineering is the book, or remains, has been for many, many years, has been the book by Dr. Chopra. I think there's a new edition, which is 2022, 23, which is still well written and internationally accepted. So it's a good book to have in your shelf, or you can borrow it from the library. I think they have it in the reserve. It's always a reference. Like I always have it once and again when I forget some topic or some details of some calculations, I go back to it and I find it in there. So it's a very nice reference to browse through, to understand it, and try to be able to, like by the end of this term, be able to find topics in there. Because not all of us have like great memory, we can just memorize everything, but we should be able to find it in the references, in good references. Another good reference, which is, it's an excellent reference for more towards design. The Chopra book is more towards analysis. This is more towards design. And I liked it. And last year I actually bought this book again. And it's now at the library, the copy that I purchased. One interesting issue is about this book, which I think is exceptional, is that for every topic, it compares both US and Canada methodologies. So you can see them side by side. Sometimes the approaches appear to be very different. So if you don't spend time, if I don't spend time, I don't really it's difficult to understand why they go so much different, but when you see them side by side, you understand that they are based on similar research and they intend the same purpose, but just the appearance is different. Yeah, very good book. The only I was waiting, I'm really still waiting to see if they will have a newer revision, which is closer to like at least ASC 2016 or NBCC 2015 or 2020, because there have been a lot of changes. But this is like, because this book has so much details in it that I understand it's a difficult task, that they should update a lot of things based on US code and Canada code. So it's already a daunting task. Like, it's a very, very good resource. And as I said, it's in the UBIC library right now. At least one copy is there. And then we will be using codes. National Building Code of Canada is the most important. And yeah, again, you should be really able to find your way in the book and try to browse through it and find the earthquake section and subtopics in the earthquake section. The very good news is that this book is now formally available to everybody for free, so you can download it from their website. As I said, one downside was that with 2020 was that it was not legislated in British Columbia. I should double check, make sure that it's, to see if it's legislated now in 2024. That's surprising. 4 years later, I'm not yet confident that it's legislated. It probably is, or it's going to be legislated this summer. But last time I checked, 2015 was legislated in British Columbia. But it's a good code and it has good improvement. I assume there are good improvements compared to 2015, and now it looks more comparable with ASC 7. So, yeah, but then, I mean, at the end, both of them lead to the same design, but now the appearance is also more similar. And then, yeah, so that's called, that's like, it's called a model code. So the people who create this code, I don't know whether it's a Canadian Commission on Buildings and Fire Codes, they create model codes, but it doesn't mean that it's legislated and it must be used. However, the more local jurisdictions later on, in 1 or 2 years, or in this case, after 4 years, they say now we legislated it and now the engineers must use them. Maybe provincially or in the cities, they legislate, and then after it's legislated, then it's mandatory. And yeah, similarly, we have a code for steel structures that we will be using. I assume that you guys have familiarity with these codes, but we will be focusing on the earthquake subsections. And this is the code for steel design in Canada, CSA S16. Last time I checked, it was 2019. So 2019 was the newest one. And there is normally a handbook of steel construction, which corresponds to the same code. And I haven't used it recently, but when I was doing some more design, it was very nice, like very nicely tabulated, and you could really avoid some calculations or double check your calculations because there are very nice tables to choose the appropriate profiles in there. So this handbook is very useful in engineering. Now the concrete in Canada is CSA A23.3, design of concrete, and which is a structural design. And again, last time I checked, 2019 was the newest one. The picture is showing 2014, but there's 2019. And again, it comes with the handbook. Yeah, for some reason I have used this handbook less often, or sometimes it's like for development land, etc. They have some nice tables, but tables in handbook of still construction, they are the best. They're very good, very, very useful. For software, I previously talked about SAP 2000, and I hope you guys have some familiarity. I try to walk you through at least one of the models as well. So it's okay if you have never used this software. So we will walk you through, I will walk you through at least one of the simpler examples in there. But to make sure that, let me know if there is issues with licenses, etc. I can contact the department and ask that the license be available. As I said, June 7, we will be presenting the shake table. I have seen the shake table. However, last year, similarly, we had one session for shake table, but then there was some difficulty and it didn't work in the classroom. It didn't work. And okay, I mean, this year I gave them heads up earlier. Hopefully, they are prepared, and we will have a nice presentation. That's always interesting to see shake table simulation, because similar to what you see in your computer model, like this is a computer model of the pseudo small structure that we will put on the shake table. And it's like reconfirming that we are really trying to model the real world and seeing the same results in your analysis comparing with the measured values on the shake table. It's like reaffirming in your mind that you're really trying to estimate the real world by computer analysis. And the model, the structural model that we will put on the shake table, it's called the Pasco model kit. We're supposed to do that. And as I said last year, we couldn't really go through it, but there was a video. I showed the video of the same thing to the students when I was in the class. And we shake this structure, which is built of Pasco, and we try to measure some deflections or displacements, etc., compare it with the computer simulation. Yeah, looks like this time we were fast, not many questions and discussions arise. And this is the end of the introduction. Now, more chance for questions. If you have, maybe I went too fast or maybe not, but I thought that maybe last year I was interrupted more by questions. About the outline of what we will do that I already sent you. That's important to know what we are going to do, and the templates I sent about the projects. That was super important to have them and use them. You are welcome to modify them a lot. I just want to, like sometimes when even myself, I want to start from scratch, that's annoying, but if I have a template, I can make a lot of changes. So you are welcome to make all changes that you think makes it better. That's what we have. At least I try to open what we are trying to go through next Tuesday. If there are no, just interrupt me if you have questions or concerns, anything. Just I go from last year, I didn't adapt it for this year yet. 2023. So That's what we will do, just showing what we will do next year, next Tuesday, which is 14th. So we try to do it on 14th. I will slightly edit it, just saying 2024, or a few other small edits, but that's what we will do next week. We will go through a single degree of freedom, generally understanding the dynamics of the structures, ground motions. We will have one or maybe two sessions on ground motions and earthquakes, but they just general the what ground motions are in earthquake, some nomenclature or terminology in earthquake engineering, what is like one degree of freedom could be in structural engineering, and the equivalent static load, which is very important. That's the National Building Code of Canada method. And other important topics, but I think it's like we don't need to do that on the very first day. But that's pretty much what we will do Tuesday, and that's ready to go from last year. So maybe if there are not many questions, we'll finish like 10 minutes early. And yeah, as I said, maybe first few days you will think about this, you will send more emails than usual, ask questions, something came up. Will we be randomly assigned to a group if we do not have one? I try not to make it random, but I will introduce the people without a group to each other, and then they will decide. So it's slightly random, but then like if there are only 3 people left, like last year, I think it was like that, even though the class was 45, 6, and then 3, 4 people were left out for different reasons, and they had no other way except to live with each other. So, I mean, I prefer, or like as if I was the student, I would prefer to work with people that I know and we have some, like we are 40 years, so we have some knowledge of each other and the people who share the same interest. Maybe. But it always happens. At the end, 3, 4 people haven't found a good partner for the project, and then they have to work with each other. Did I answer your question? Was it okay? Yeah. Actually, because I went to last year folder, maybe I can see just randomly open one of them. As I said, the most important, one of, I can say the most important, but one of the important parts of that work plan is that you really think and put your hours in that table that I showed you. You are the best judge. So you can really say, if I want to run SAP 2000, I need 6 hours. I let me put 6 hours in there and then add up your hours so that you don't overburden yourself. So that table will help a lot that you don't over promise and then be in trouble. But I also try to be careful with that as well. And also say one of the groups, they had something like this. Let us see if there's PDF. This is the report. I can see the report over the presentations. Okay, let's have this. Right. Just go quick. Say this is not hugely even mathematical. So, but they had done okay research and they had some points to make. And everybody appreciated that. Like we learned, as I said, from many of the presentations, everybody learned. So that we opened a good example because it's not, but they have some analytical thinking and checking on some numbers as well. And then their references, what they had studied. We had some other presentations which were like completely a design project. Yeah, let me. Yeah, okay, I don't see a follow-up question, but yeah, hopefully this is helping you see the level of the work that was done last year. They were mostly okay, like okay projects, and you use. I enjoy most of the presentations myself. Some study on the effect of different types of bracing. Some attempt in modeling using SAP 2000. Yeah, so they have tried to make the presentations enjoyable as well. Did it help? Did these two presentations that we browsed, did it help you? Okay, yeah, sounds good. Okay, yeah, tell me if there are questions that I can answer now or concerns. Okay, yeah, I can give you like about 1 more minute and then we close off. I'm hoping that everybody has a very enjoyable weekend. And as I said, on Tuesday, we will be focusing on single degree of freedom structures. Already? Yeah, thanks a lot. Talk to you guys Tuesday.
Thanks.
Thank you.
Thank you.
All right.
I have one more question.
Yeah, sure. Yes.
You mentioned that you will share some material about the topics you mentioned, like recommended in the online. So
Right.
will it be sent to everyone, or it's like if we are interested in certain topic and we send you an email and then you share with us?
I don't want to confuse people or like make them think that they should do exactly as previous year. But if you say you are interested in damping, and I know that last year we had some damping, I can show that to you, and then you have a better start. Then you can continue their path or branch out to a different type of damper. Maybe that's what I'm thinking. But if I give all of them to the students, then it will be confusing.
Okay. Yeah.
Yeah.
Thank you very much.
All right. Okay.